Hi all, I am Aravind Kannan. Our project is Smart Power Management System in Multimeter and my teammates are.
Blasenbal. I am currently pursuing my BE in Electronics and Communication Engineering, National Engineering College, Kovilpatti.
Myself Bobalan. I am currently studying third year Electronics and Communication Engineering.
So our project objective is to develop a portable digital multimeter integrated with a dual power sources like solar panel and USB type B charger to ensure continuous operation and reliability of multimeter by incorporating an effective power management system for switching and battery charging. To promote energy efficiency and eco-friendliness by utilizing renewable solar energy as primary or backup power source for electronic measurement. Abstract. Conventional multimeters depends only on batteries, limiting using time and requiring frequent replacements of the battery. Lack of reliable power sources in remote or field environmental hampers continuous usage of measurement tools. Implement a dual power system combining solar panel and USB Type-B charging with smart power management, a sustainable portable multimeter capable of uninterrupted operation in both on-grid and off-grid conditions. Introduction. Actually, a digital multimeter is an electronic measuring instrument used to measure various electronic quantities. The standard measurements that performed by digital multimeters are current, voltage, resistance, continuity test, and diode, etc. Used in circuit testing, troubleshooting, and any electrical measurement. This is also called as volt ohm milliammeter. This is an existing technology background block diagram of a multimeter. So in that constant current source is given and a rotatory switch will be there and input probes will be there. And inside the multimeter we can see that buffer amplifier and calibrator attenuator and current to voltage converter will be present. Gap identified. Short battery life. Many standard digital multimeters have limited battery life requiring frequent replacement. Continuous backlight usage drains battery faster. Non-rechargeable battery in many models. Standard digital multimeters use normal batteries leading of frequent replacements. Rechargeable options are not there, increasing waste and operational cost. Manual data recording. No built-in memory to store multiple readings. No USB or SD cards. Slot for offline data transfer. No automated test sequence for repetitive machines. Performance degraded at low battery lives. Some digital multimeters provide incorrect readings when battery voltage drops below the certain level. Measurements accuracy may decline without an automatic shut-off mechanism to prevent false readings. Existing components and display and a rotatory switch and connection ports and a battery, AAA battery, buzzer and probes and ICL 7106 IC and resistors. And this is the PCB layout of the multimeter that is present inside. Data sheet written, extraction. So these are the data sheet written that we have taken and the roles of the components. The display is used to a LCD screen to show the measured values and readings. Measurement probes are used to measure the values of accurate voltage current and ADC analog to digital converters which converts the analog signal to digital signal. Voltage divider is used for measuring high voltages. Current and resistor is allows current measurement by sensing the voltage drop across a known resistance. Protection circuit protect internal components from over voltage or over current and polarity reversal. Rotatory switch which enables a selection mode. Buzzer it is used to check whether the continuity is there or not. Battery in multimeter we use 9-volt battery. Proposed forward engineering to develop a digital multimeter with dual charging operations like solar and a port. This innovative approach aims to enhance portability and sustainability by utilizing renewable solar energy, reducing the dependency of disposable batteries. The device will provide accurate measurements for voltage and resistance while ensuring continuous power available through the efficient power management. By integrating both charging methods in multimeter, we will offer users a reliable, eco-friendly, and cost-effective solution suitable for various applications. This is the proposed flow chart. Also check if solar is available, charging the battery with via solar panel, or checking the port connection and charge via the battery via the port. This is a proposed block diagram of the forward engineering. Instead of the constant current source, we have using a battery, and the battery is getting charged by a solar panel or USB B-type charging port. And this is a circuit diagram of innovation. And this is a simulation result using Tinkercad. And this is our product's image. And the financial setup, the digital multimeter cost of 250 and solar panel of 6 volt of 350 and rechargeable lithium ion battery 9 volt 300 TP4056 charging module 100 step up boost converter 100. And this is the customer survey that we have been undergone. So this is the video recording of this video. Conclusion: the solar powered digital multimeter with dual charging enhances sustainability and efficiency by integrating solar and port charging. This design reduces dependency on disposable batteries, making it eco friendly and cost effective. This project proves the feasibility of renewable energy in handheld devices, paving the way for future advancements like wireless data logging and higher precision. Future scope: upgrade the USB Type B port to Type C port for fast charging and compatibility with modern devices. Integrating wireless connectivity such as Bluetooth or Wi-Fi to convert transfer the readings. Upgrade to an OLED or touchscreen display for better visibility. Develop a mobile app to view real-time readings and save management. And these are the references that we have been taken for the battery management system and the construction and working implemented. Thank you.